Welcome back, my dear students. Now we will study one more parameter in this compaction chapter. In last class, we studied the definition. In previous classes, definition we studied, and after that we understood the meaning and effects of compaction, and after that light compaction and heavy compaction we studied. Okay. However, now you come to know, you already know how you will get the compaction curve. Okay, once again I will tell you the first trial, either it is a standard compaction, or light modified compaction. Okay, either standard or modified. But here you will do some that test, compaction test, either 3 layer, 5 layer, whatever that specification is already explained in previous class, that you will do, and after that you will get a bulk density, right? You will get a bulk density, and after that bulk density you need to convert it into dry density. Why you want dry density? To draw the graph. See, here this graph is there. This graph requires a dry density and moisture content, right? Therefore, if you know the bulk density from the test, and after that this bulk density you need to convert it into dry density. To convert this bulk density to dry density, you used the equation gamma d equal to gamma b divided by 1 plus w. This equation you used, yes or no? Yes, sir. You used this equation and converted bulk density to the dry density. But I have another equation for dry density, that is gamma d equal to 1 minus Na into g gamma w divided by 1 plus wg. See, this equation also I have. Here also you are getting a gamma d. Why can't you use this equation? Sir, if I want to use this equation, sir, I should know first what? I should know first what is Na. Na means what? This is the air content. Sorry, percentage of air voids. Yeah, percentage of air voids, you can get it. You can get it. Sir, how to get it, percentage of air voids? Yes, you do some core cutter test and all. Some other means, whatever that is, I don't tell you because in the first chapter I already told. You think that you know percentage air voids. Okay, pa. Then sir, I don't know this specific gravity. Okay, don't worry, take the soil and go to the lab, use pycnometer or density bottle, and there by using pycnometer you can get the specific gravity. Yes sir, you are right. Then sir, I don't know gamma w. Where gamma w, what is there in the gamma w? That is the always constant 9.81 if you want in kilonewton per meter cube. 1 gram per centimeter cube is we are using in gram per centimeter cube. Therefore gamma w is always known to you. Nothing to worry about gamma w. Okay sir. Then what is left here? You want W, means everything is known, no? Then you know the water content variation. By using this water content variation, you can get a gamma D. To get a gamma D, you have two equations, either this equation or this equation. Okay, now if you use this equation according to Proctor, if you use this equation and write the gamma D, then you will get a graph this way. You will get a graph this way. Then curiosity comes now. Sir, what happens if we use this density formula and calculate the density and draw the graph? What happens? Then you will get the graph this way. This way you will get. See, this graph will not give you what? OMC and MDD. OMC and MDD. Okay, what was our aim and objective of your test, standard density and modified density? Why we were doing? To know OMC and MDD. That is why I did not use this equation. That is why I used this equation. Therefore, this equation was not used. Okay, sir. Then when we need to use this equation, then the answer is very easy. When you know Na, comedy, no, right? When you know Na, then you can use this gamma D, right? Then the question comes. Then this, that question we will see it later. And then this line is called as air wide line. Air wide line. Air wide line. Air wide line. Okay, na? Then, sir, if Na is not known to us, then what? If Na is not known to you, then what? then you need to do some other tests, like how you do specific gravity test, like that you need to do some other test and you need to get it. That I don't explain in detail here. Let us consider if Na is not known to you, then take Na equal to 0. Array, why sir? Na equal to 0. Then come here. What is the meaning of Na? I will write it here. What is the meaning of Na? Na is volume of voids to the volume of air to the volume of total volume. Sorry, this is the Na. If Na equal to 0 means Va equal to 0. How come sir? How come Va equal to 0? You make sure that you are adding water more than shrinkage limit. What is the shrinkage limit? Then you need to study the previous chapter. Shrinkage limit is the minimum water content at which soil will get saturated. If you are adding more than shrinkage limit water, then obviously you are replacing all air by water. In that case, Va becomes 0. In that case, Va becomes 0 and you can substitute Na equal to 0. In that case, that is called as 0 air wide line. 0 air wide line. That is called as 0 air wide line. Why we need to do like this? Why we need to consider Va equal to 0 to get maximum theoretical dry density. See, in a first slide only I told you that removal of 100% air voids is impossible. But still you are considering Va equal to 0 theoretically. Practically it is not possible. Theoretically you are considering Va equal to 0 means this becomes a theoretical maximum dry density. Right? That to know the theoretical maximum dry density you are going to do that. That is why the heading is 0 air wide line. The line which shows the water content dry density relation for the compacted soil containing the constant percentage of air voids is known as air wide line, and that can be established by following this relation. Okay. Theoretical maximum compaction of any given soil given water content corresponding to 0 air voids condition. Theoretical maximum dry density when you put Na equal to 0, then you will get theoretical maximum dry density line. The line showing the dry density as a function of water content for soil containing no air voids is called as 0 air void line or saturation line. That is very important. Okay. Therefore, we are going to do this 0 air void line. Going to the other heading, that is compaction energy. Very important. Sometimes very important for competitive exam point of view. What do you mean by energy? See, here the question why we need to study is, you know the soil. That soil you are putting into the layers, 1 layer, 2 layer, 3 layer in standard, 5 layer in modified. But you are putting some amount of energy to the soil. You are hitting that soil. That means that soil is gaining some energy. It is storing some energy in it. That how much energy it is storing, that I want. Okay. Therefore, in our physics, in PUC or in there, if you go, then you will come to know the meaning of energy. Energy is force applied for a particular distance. And that force applied, we can call it as a work done. This work done for a particular volume is called as energy. Therefore, how much force you are applying, at what distance you are applying, and for what volume you are applying, that we are going to study here. See, first I will calculate compaction energy for light compaction. Light compaction can be done by 1000 centimeter cube mold, and that can also be done by 2250 centimeter cube mold. 2 molds you can use it for this light compaction. Okay, na? This in light compaction, what you do? You have a 2.5 kg hammer. This 2.5 kg hammer, right? This 2.5 kg hammer means that I can say it is a force. This is a force. 2.5 kg hammer, you are dropping it from what height? You are dropping it 2.5 kg hammer from 310 mm distance. Okay, but you are not doing this one for one time, you are doing it for 25 number of times. You are 25 number of times you are dropping it, and you are not doing it for one layer, you are doing it for 3 layers. Okay, therefore this is becomes the total energy, and this total energy is occupied in a volume. How much volume? This is a 1000 centimeter cube volume. See, this 310 has a some, we will consider as 31. Okay, not 310 because this becomes mm. 31 centimeter, this become a 31 centimeter. This don't have in it, this don't have in it, and kg centimeter per centimeter cube. This is a compaction energy. Then how much you got? Just check it. 2.5 into 31 into 25 into 3 divided by 1000. Okay, you are getting 5.81. You got 5.81 what? Kg centimeter per centimeter cube. Okay, this is the compaction energy. Now let us consider for this bigger mold. Same here also you are using the 2.5 kg hammer only, and that hammer is dropped from 310 mm because light compaction, and but because of the bigger mold we are using 56 number of blows, therefore, and 3 layers only we are using, and the mold size is 2250. Therefore, what amount answer I am getting? 2.5 kg into 310 mm, 31 into 56. This you make it 31. 56 into 3 divided by 2250. Then you are getting 5.78. 5.78. See, almost same now. 5.8, 5.78 both are same. Means what? You use 1000 centimeter cube or 2250 centimeter cube, you are putting the same energy to the soil. Same energy to the soil. Same energy to the soil. Once again tell, you use 1000 centimeter cube mold or 2250 centimeter cube mold, you use 25 number of blows or 56 number of blows correspondingly, but you are putting same energy to the soil in light compaction. When you come to the heavy compaction, see, the heavy compaction can be done in 2 molds. One is 1000 centimeter cube mold and the second one is 2250 centimeter cube mold. Then here we are using 4.5 kg hammer. That hammer will drop from 450 mm means 45 centimeter, and that will be dropped for 25 number of blows for smaller mold, and that will be dropped for 5 layers. We are going to do the test divided by 1000. Then the answer what you are getting here is 4.5 into 45 into 25 into 5 divided by 1000. That answer you are getting 25.3. 25.3. Okay, then in this compaction in the bigger mold, same 4.5 kg hammer you are using, 45 centimeter drop you are using, 56 number of blows bigger hammer, and 5 number of layers you are doing. Therefore divided by 2250, if you do, you must get how much? The same answer, 4.5 into 45 into 56 into 5 divided by 2250. His answer is 25.2. 25.2. See, either you use 1000 cc mold or 2250 cc mold for heavy compaction, you are putting the same energy to the soil. That is how much? 25.3 kg centimeter per centimeter cube. Now one more difference you got compared to light compaction and heavy compaction, that is in light compaction you are putting the energy 5, and in heavy compaction you are putting the energy 25. Means heavy compaction is how many times heavier? 4 times or 5 times? 5 times heavier, right? Heavy compaction is 5 times heavier than the light compaction. Very good one, right? Thank you very much. Just pause the video and go back and rewind it many times and study it. Thank you very much. We'll end the lecture here. Thank you.